welcome to homework day 9. Hopefully you found this okay, and we're getting used to doing these videos. What's unique about this one is I'm going to ask you to start this packet without watching the video. Okay, so do you remember plotting coordinates and identifying coordinates on a graph? Okay, so I want you to pause the video, try numbers 1 and 2 on your own, and then come back to me when you're ready. Okay, hopefully at this point you were able to try these on your own, kind of like a warm-up to tonight's homework. What you should have gotten was that P was located at -4, 2, Q was located at -3, 0, R, -4, -1, S, -3, -2, T, 0, -3, U, 7, -2, V is at 2, 2, and W at 4, 1. Okay, remembering that your X value always comes first and then your Y value. Go ahead and correct any mistakes you may have made. For number 2, okay, plotting points, the coordinate 3, 2 means over 3 up 2, label it S. 0, -1 is T. Over -4 down 2 is U. Over 4 up 0 is V. -2 up 1, that's a W. And lastly, we have Z at 2, -2. Hopefully you did okay on those. They should be review from last year. And now we can really dive in. And our focus tonight is on proportional relationships in a graph. Okay, so if you're able to understand the tables and the equations we worked with so far, the graphs will be a piece of cake. So here we go. It says each time the wheel on Mike's unicycle goes around, the unicycle moves forward 2 meters. Okay, so every time it goes around, moves 2 meters. The table below shows the relationship between the number of revolutions and the distance the wheel moves. Is this a proportional relationship? Okay, so hopefully you're remembering from what we've been doing that every time you have a table, in order to see if it's proportional or not, we need to make ratios of y over x and see if they're equivalent. So the first ratio would be 2 over 1, which equals 2. The next would be 4 over 2, which equals 2. And then lastly, 6 over 3, which equals 2. So we would say, yes, this is a proportional relationship, and the reason it's proportional is because each ratio of y to x is equivalent. Okay, and anytime they're the same or equivalent, we say that this is proportional. So now that we know it's proportional, we can find our constant of proportionality. And it's that value you are getting over and over and over again. K equals 2. Feel free to pause, rewind, rewatch, jot down any questions you have, and now we'll look at the bottom portion of this. The graph below depicts this relationship. What are the coordinates of the points on the graph? Okay, so I'm seeing 0, 0. Okay, over 0, up 0. I'm seeing over 1, up 2. I'm seeing over 2, up 4. And over 3, up 6. And if you notice our table, those were the pairs we had up here. Over 1, up 2, over 2, up 4, over 3, up 6. So we would just take in the table and put it into coordinate form on a graph. And then this asks you, what do you notice about the shape of the graph? Take 30 seconds to brainstorm them. What do you notice about the shape of the graph? Hopefully we're recognizing that it's a straight line. Okay, no curves to it at all. Now this is a very, very important question. What point or which point can be used to find the constant of proportionality? Okay, remember, constant of proportionality is that value you're getting every time. And if you remember up here, 2 over 1 equal 2, 4 over 2 equal 2, 6 over 3 equals 2. So it's really this relationship right here that's representing that value. So we would say that this point represents that 2. And the key is you want to find where x is 1 and figure out what your y value is. And this is always going to be your k. Okay, now if you think about what this really means, okay, that means 2 meters per 1 revolution on the bike. Okay, 2 meters per 1 revolution. Well, what's another name for that? Okay, besides constant of proportionality, we can also call that our unit rate. And that's very important. That's a very common question for a test. Hint, hint, wink, wink. You can always find unit rate where x is 1, figure out your y value. That's your k, that's your unit rate. Very common test question. And the last thing we have here is, what does the 0.36 mean in the context of the problem? Okay, well, over 3 up 6 means we have 3 revolutions and 6 meters. Okay, so I would say 6 meters in 3 revolutions. Feel free at this point to pause, rewind, rewatch, jot down any questions you have, then flip the page. This is the heart of what you need to know. A graph represents a proportional relationship if it is a straight line and passes through the origin. And the origin is 0, 0. It's your starting point. Okay? So it really is that simple. And we have some to practice here. If I look at number 1, does this graph represent a direct proportion? Is it straight? Yes. Does it go through 0, 0? Yes. So yes, this is proportional. And if so, it must have a constant of proportionality. We always find that where x is 1, pick out your y value. K equals 10. Okay? And if you wanted to pull points off of this and make your ratios, you could. This would be 10 over 1. This would be 20 over 2. And this would be 30 over 3. And they all equal 10. And that's your K. So now we can write our equation. Remember, our equations are always in y equals kx form. We would have y equals 10x. Number 2. Is it a straight line? Yes. Does it go through 0, 0? No. So this is not proportional. If it's not proportional, we don't have to worry about the constant of proportionality or the equation. Okay? Number 3, is it a straight line? No. So it's not proportional. It really is that simple. Go ahead and flip the page. On this page, you have 3 more. I want you to try them on your own, and then when you're done, unpause the video and come back to me so I can go over them with you. Okay, so go ahead, pause, try them on your own, and come back. At this point, hopefully you've tried these on your own, and they should be pretty easy. Number 4, is it a straight line? Yes. Does it go through 0, 0? Yes. So it's proportional. Your constant of proportionality is right here. K equals 20, which means your equation is y equals 20x. Number 5, is it a straight line? Yes, but it's not touching that 0, 0. So no, not proportional. Number 6, is it a straight line? No, not proportional. And it really is that simple. On the next page, you have just a couple to try for yourself. These are the ones I'm going to be looking at tomorrow in class to make sure they're done. Have a good night.